What is that, math peeps? It's Mr. here with lovely little Emily down here with her broom. Um, this is the last edition of the SBAC prep, so thanks for making it through if you made it all the way through. We're going to just go over the last few questions of the review that I found. Just make sure that, again, if you want to take advantage of some extra credit here, that you're watching through the video and taking as many notes as you need in order to be successful here. So let's take a look at the problems and let's keep on going until we finish. Let's go.
Let's hear it. Let it go. Let it go.
Hold it back anymore. Let it go. Let it go. Put it back inside the door. All right, so number 28 here requires us to take a couple of steps to make sure that we're understanding what the problem's asking us to do. So 28 states that a biologist tracks the number of bacteria living in a water tank. Now the biologist found and used a function that represents the amount of a certain chemical solution that you're using and you're adding to the water. So it gives us two facts as bullet points in the middle here. It says when the water has no chemicals, meaning that we haven't added anything to it, the number of bacteria is 1,200 per gallon. For each tablespoon of the chemical that we add, so C, to each gallon of water, the number of bacteria decreases by 75 per gallon. Now it's asking us how much of the chemical in tablespoons do we have to add to a 500-gallon tank to reduce the bacteria count to a safe 300 bacteria per gallon. So here's how we need to think about this. The first thing that we need to think about is what our target goal is. Now our target goal is that whatever we add in the amount of chemicals, that our final product is going to be 300 bacteria per gallon. So here's how I'm going to set up my equation. I know that 300 is going to be my target. Whatever I do to get to that 300, this is where the function actually comes into play. So here's what I know. I know that when we start, every single gallon of water has 1,200. But when we add the chemical, what we take away from it is about 75 of those particular bacteria being destroyed per gallon that we use. So here's my equation. My equation says this. If I want 300 in total, starting from 1,200, I'm going to take away 75 of those bacteria for every tablespoon that I get. So what I'm going to do now in green is I'm going to solve for C. Now this is just a two-step equation, and here's how you go about solving it. So I subtract 1,200 from both sides. 300 minus 1,200 gives me 900, so I'm going to continue this work down below. So I have 900 is equal, or negative 900 is equal to negative 75C. And once I divide both sides by negative 75, I'll get how many tablespoons I need for every gallon to decrease it to 300. So the number of tablespoons that I need, so doing some quick calculations here. So definitely make sure that you have your calculator on lock here so that you can do some of these calculations. So once I do 75 divided by, or 900 divided by 75, I get 12 tablespoons. Now be careful here because this isn't the answer that they're asking you for necessarily, because if I have a 500-gallon tank, I need to take that many tablespoons because this is per gallon. And since I've got 500 gallons, I need to multiply this number by 500 here. So 12 times 500 gives me my final answer, which means that I need to, in total, do 6,000 of these tablespoons. Pretty crazy. So again, one of the biggest things here is that we took two steps. Step one was creating our formula, and step two was making sure that we solved it and put it in terms of the way that the question was being asked. Definitely not the easiest problem in this set, but definitely something that if you took enough time to practice, you'd be able to work through for sure. Number 29 here requires us to fill out a table with a few essential pieces of information. So it says Samantha gathered the following information on a given day at the dog park. There are 32 dogs playing in the dog park. So my first piece of information, I can fill out one piece in my table here, and that's the grand total. Now this table separates dogs into separate categories, but one thing that we know is that in total there are 32 dogs in the park. So we know that 32 goes in that bottom right hand corner because that is the total dogs in this park. The second piece of information says 15 of the dogs are puppies. So let's look for the category that says dogs that are puppies, and we know that in total down here there are 15 of them. Cool. Now once we do this, here's something that we can definitely use our critical thinking about. If I wanted to find the amount of dogs that aren't puppies, all I need to think about is how many more dogs I would need to get to the grand total of 32. So if I have 15, what I need to add to it would be 17 in order to get that grand total of 32. So even without being given that piece of information, I was able to reason my way through filling out a piece of information on this table. The third piece of information is a more specific entry, so it says 11 of the dogs are not puppies and have long hair. So if I'm looking for the piece of the table that represents that, this little box piece in the table are dogs that are not puppies and have long hair. So there's exactly 11 of these guys that fit into this category. Now last but not least, they gave us a piece of information that states there are 6 more dogs that have long hair than dogs that do not have long hair. Now whenever you see a statement that might look like this is definitely a very good indication that this is going to be a systems of equations type of question. So one thing that you got to make sure that you're able to do is define some variables here. So that last piece compares 2 different characteristics, dogs with long hair and dogs that do not have long hair. So I'm going to put an X and a Y next to these 2 characteristics that we're trying to describe. So the statement again says there are 6 more dogs that have long hair than dogs that do not have long hair. So if I were to try and create an equation that this statement describes, we know that there are 6 more dogs that have long hair, so X plus 6, compared to the dogs that do not have long hair. So this is an equation that I can create in order to identify and sort of fit into that description. Now, another piece of information that I know from the very beginning is that no matter what, when I add these 2 categories together, I'm going to get 32 dogs in total. So nothing more, nothing less than 32 dogs at this dog park. Now, if you recall, one of the strategies that we were able to employ when we were solving systems of equations is substitution. So when I substitute here, what I can see is that the y's match. So wherever I see a y in my first equation or in my second equation, I can replace it with an entire expression. So in green here, here's my next step. I would take x plus, plugging in what y is equal to, x plus 6, and I would find out what x would be equal to here. Now remember what x stands for. It's the number of dogs with long hair. So doing a little bit of simplification, here I get 2x plus 6 is equal to 32. Subtract 6 from both sides, and I get 2x is equal to 32, so 26, and I get x is equal to 13. Now here is where we need to make sure that we make sense of our numbers. X equals 13 is the grand total of dogs with long hair. Now, believe it or not, with these pieces of information, I have enough to fill out the rest of the table. So without doing any more math, here is how I can do this. So if I know that I have 13 total in this column, if I already have 11 accounted for here, I know that I only have 2 more left here. Now, going downwards, if I have 2 in this category, and I know I have to add up to 15, I know that I can only have 13 in this missing category here. Going downwards again, if I have 11 in this top category, I know that I have to add 6 to it to get to my grand total of 17. And last but not least, 13 plus 19 here would give me my grand total of 32. So this is sort of like a Sudoku puzzle in which you got to try and find the missing pieces and try your best to sort of reason your way through filling in the missing gaps. And this is your approach whenever you see a problem that might look like this. Now, just like in the problem before, this is a straight up systems of equations problem. So there's no bells and whistles about this, no scenarios that they try and set up for you. And this is straight up an elimination problem. So I'm going to write elimination nice and big. Now remember, when we eliminate, we choose one of our variables to cancel, but in order for them to cancel, they need the same number and different signs in front. Now, I can choose either X or Y here, but the one that I'm going to choose to eliminate is going to be the Y's. Now, the reason behind doing that is because I can see that 3 and 6 are pretty close to being the same. I just have to change one of my equations to make the numbers to match. So what I'm going to do in red here is I'm going to change my top equation by multiplying it by 2. Now remember, when I multiply by 2 and I find that number that I'm going to change it by, I multiply it to every single term here. Now once I multiply this top equation, I get a brand new result, and the result would be -4. So again, I'm multiplying that 2 up front, plus 6y is equal to, and then that 2 times -6 gives me -12. Now once I bring my second equation back down, you'll see that the work that I did in changing that equation allows me to eliminate one of my variables. So in this case, what I can eliminate is I can eliminate the y's now. Now once I do this, all I need to make sure that I'm able to do now is I need to make sure that I'm able to solve for x. So -4x plus 5x gives me 1x. And on the side over there, on the right hand side, I have -12 plus 15, which gives me 3. So I get x is equal to 3 here. Now realize that the biggest thing that you need to make sure that you are doing is answering the question like always. Now I found out what x is, but it's asking me for the y coordinate here. So you know the drill, you know how to find what y is. In order to find out what y is, I take x and I plug it back into one of my equations. So it doesn't matter which equation you plug it into. For instance, I'm going to plug it into this bottom equation here. So if I have x is equal to 3, I have 5 times 3 here, minus 6y is equal to 15. And now I just got to solve for y. So I get 15 minus 6y is equal to 15. Subtract 15 from both sides and you see something weird happens. I get -6y is equal to 0. Divide both sides by -6, and I get my y value here that I'm going to put in purple because this is my final answer. I get y is equal to 0 as my final answer. Now this again is a very straightforward elimination problem, so don't get intimidated by it. You might just need to brush up on your elimination skills to make sure that you're working your way through this with the steps that we went over in class. All right, so number 31 here is one of our favorite select all statements. So that means automatically that we can have multiple correct answers here. And it states the ratios A to B and B to C are equivalent to one another. It asks us to select all the statements that have to be true. Now here's something that you can employ that'll help make your life easier whenever they give you expressions that just have variables in them. What I'm going to do is I'm going to pretend that these variables are actually numbers. So I'm going to pretend that A is 1 and B is 2. Now that I've set those requirements, here's what I need to be able to compare. So the ratios can be written just as fractions. So if I have 1 over 2, if it's equal to another ratio in which I'm using B, which is 2, what would the denominator be in order for these guys to be equal? So this would be what C was equal to. So 1/2 should be equal to 2 over 4 here in order for them to be equal to one another. Now, if you're thinking to yourself, how does that help me answer this question? What you have now is you have all of these variables defined. So I have A is 1, B is 2, because it's the same ratio as before. So B is 2, and now I know C is 4. So if I were to go through each of my statements, I can determine whether or not they're true. So if I look at the first statement, A is equal to C, what I can do is I can take my A value, which is 1, so again I'm just using the information I have up above, and I'm going to see whether or not it's equal to my C value, which is 4. Now I know that's not true, so the first option can't be correct. Next one, I'm going to use all of my values again to rewrite this equation. So my b value is 2, as it states up above, over my a value, which is 1. And is that equal to my c value, which is 4, over my b value, which is 2. Now what you can see here is that this is definitely a true statement, and bada bing, bada boom, I've got one of my correct answers. Now you can keep on going through this process, and the strategy here is to choose your own numbers to make this less of a conceptual problem and more of an actual sort of specific problem once you choose numbers that are easy to work with. Number 32 is definitely a super easy problem, especially when you realize that it's just a plug and chug type of problem. It gives you a cone with the radius and the height, and what it wants you to find is the volume. So here's the only equation that you need to find the volume of a cone. So it's almost like a cylinder, in which it starts out as pi r squared times the height. But since it's a cone, we know that it's a third of that value. So once you know this formula, all you got to do is plug in what you know. What I know is that the radius is 6, so it's pi times 6 squared times 15 all over 3. And at this point, this is a calculator problem. So I'm going to put dot, 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 because now all you have to do is plug it into your calculator and make sure that you're multiplying correctly here. So it says to round to the nearest hundredth. That's 2 decimal places. So just make sure that you plug this into a calculator and figure out what that answer would be to 2 decimal places. All right, last problem here looks similar to another problem that we covered, and that was when we filled in the table with the dog park. So if you go back a few minutes, you can see how we attacked that table problem. This one says there's a total of 500 students in grades 1 through 5 in an elementary school. 17% of the total number are in first grade. 19% of the total number are in fourth grade, so on and so forth. So here's what I can figure out. If I know what my total is, I can definitely find percentages. So in order to find percentages, all I need to do is multiply by those percentages and the total. So if I have a total of 500 students, say for the first piece of information, if I want to find the total number of first graders here, I take 500 and I multiply it by 17%. So 17% is just 0.17. And again, that is a calculator problem, so make sure you have your calculator ready to make sure that you have those numbers. The second piece of information I can do much the same way, just with a different percentage. So 500%, or not 500%, 19% of 500 gives me my total fourth grade students. So again, I take 500 and I multiply it by 0.19, which is 19%. So doing a little bit of calculation for both of these things, and again, make sure you've got your calculator ready to use. Here is what I would get from my grand totals. So if I do so if I do 500 times 0.17, I get 85 students here. Cool. So there is my answer for first grade. If I do 500 times 19, or 19%, I get 95 students. Now using my next pieces of information, it says the number of third grade students is 9 less than the number of fourth grade students. So if I do 95 and I subtract 9 from it, what I should get is my grand total of third grade students, which is now 86. So if I do 95 minus 9, I get 86 students here. Now what you can see is that I've figured out 3 of these boxes just by the 3 pieces of information. The last piece says this, the number of second grade students is 10 less than the number of fifth grade students. Now if you think back to that table problem, one thing that you can definitely remember is that a statement like this tells you that you're probably going to have to set up a system of equations. So the number of second grade students, I'm going to assign a variable, and in this case I'm going to assign x, and the number of fifth grade students, I'm going to assign a variable, I'm going to say they are y. So if I were to set up a statement that relates these two together, the number of second grade students, which is x, is equal to 10 less than the fifth grade students. So if I have the fifth grade students, I know that if I subtract 10 of them, it will be equal to the number of second grade students. Now here's the deal. I don't know what my total value between these two grades would be unless I use some critical thinking skills here. So the first thing that I need to do is I need to add up all the students that I already have. So all the students that I already have is the 85, the 86, and the 95. So if I were to add 86 to the 85 to the 95, I get 266 in total here that I already have accounted for. Now figuring out how much I have left is nothing more, nothing less than just subtracting it from 500. So if I subtract it from 500, I have a grand total of 234 students that I know are still unaccounted for. So what I have here in red now is I've got my system of equations. Now if you go back to a couple of problems ago, you know that this is nothing more, nothing less than just a substitution problem now. So finding these two values require us to solve using our skills of substitution. So using some substitution here, I know that what I can do is I can plug in for the x value in my second equation. So I'm going to take y minus 10 and then I'm going to replace it where there's an x in my second equation. So this gives me y minus 10 plus y is equal to 234. Now if I wanted to solve this, I just know that I'm going to combine the y's to 2y minus 10 is equal to 234. Now again, you need to make sure that you are combining like terms and making sure that you're solving correctly here. But what I get is y is equal to 122 for the y's here. So the 5th grade class is 122 students large. Now I only have one more box remaining, and in this case I know that y minus 10 is going to give me my x as stated above here. So all I'm going to do is subtract 10 from that total number, and I get 112 for my total 2nd grade class. So this again doesn't have super complex mathematics going on, and more often than not, it's really just a few addition multiplication problems that you have to make sure that you're keeping straight in order to answer questions like this. So please don't get intimidated. Work your way through as much as you can, fill in as many of the boxes as you can, and make sure that you're just trying your best on these questions and don't leave them blank. All right, so that's all, folks. So thanks for making it all the way through. Again, all I can really ask you is just try your best on this test and just show them what you know. So just do the best that you can. It by no means is the easiest test in the world. So if you struggle, just keep on going and try your best on it. Emily, come here. Come here. Oh, she ran away. Well, Emily says good luck, and I say good luck as well. So thanks for tuning in, and hopefully I can post more videos before the end of the year. So peace out. Thanks again.